Hello everybody, welcome to a video on momentum. This is an introduction and we're going to just be going through the definitions, how to describe it, and then a couple of examples using the momentum formula. So let's start. Defining momentum. As you can see there, we've got a picture of a bowling ball and pins on a bowling alley, and this is a game that solely relies on momentum. Essentially, momentum is the kind of force an object will have upon itself dependent on its velocity and the actual mass of the object. So bowling pins are quite heavy by themselves, but bowling balls are even heavier, and when thrown at a velocity down that lane, they will impart energy into those skittles, kinetic energy, and blow them away, right? And so because that bowling ball has a certain amount of momentum, it is able to do its job. So you can see here we've got the definitions of it's a property of all objects and it is dependent on their mass and velocity. And in fact the formula is literally momentum symbol P there with a vector arrow of an object is the product of its mass and its velocity. And so due to the fact that it's got a vector as one of its quantities, its velocity, we would say that momentum is always a vector quantity. It's in scientific international units, so kilograms or meters second. You can see that really clearly because kilograms would be directly from its mass and meters a second its velocity, and they're the product units. However, we can simplify this into sec newtons. So on one side here we've got maybe 1 kilogram meters a second of momentum of a bowling ball or a pin or some other object that we might be able to describe, and effectively what we've got there is when we multiply it by 1 second, to keep the equity between the two, we end up with kilograms meters a second. We're literally drawing that second out of the meters a second here, converting that into an acceleration. And as we know, mass times an acceleration is equal to a force, and forces are in newtons. And so what we do is we replace kilograms and meters a second minus 2 with newton. Where does our second go? Well, we have divided by both sides here to remove it, and that's given us kilograms and meters a second minus 2. However, kilograms and meters a second minus 2 isn't our original units that we had, and so we need to go back to that. And so to do that, we're now multiplying by a second, so we would have multiplied by 1 second in here, and we did the same on this side, hence why we have sec newtons as our units. And so 1 kilogram meters a second to the minus 1 is equal to 1 sec newton, and that's how we can describe it. So we're going to have a look at some worked examples now, for example with our bowling ball. So we can know that our bowling ball has a mass, and given the picture here, it's obviously whipping along with some velocity. What those are is a mass of 0.1 kilograms and a velocity equal to 1 meters a second minus 1, and this is going, in this situation, our bowling alley happens to be lined up to the east. So following our 4Fs method, okay, the 4 Fs that we need to keep in mind, we've got our facts here, which is handy. And now we're going to go on to our formula. And if you remember, our formula is momentum equal to mass multiplied by velocity. And so we then have to add in those amounts. Momentum is equal to 0.1 multiplied by 1, and thus when we go and do the find it sections and then fix it sections of our 4F method here running down, we can find that we have got a momentum of 0.1 sec newtons east. You'll have to excuse my dog there. And there you go. That is the momentum that our bowling ball would have had. So you could convert that into written if you so wish. So looking at a more complex worked example now, we've got a question here which is asking about which object has the greater momentum. we've got a car with a mass of 1,000 kilograms traveling at 20 meters a second and a truck of mass 5,000 kilograms traveling at 10 meters a second. So we're going to follow our 4F method, as you should know. Now the 4F method goes facts, formula, find it, and fix it. And all of these steps should be clearly visible in your answer. So just a reminder on how we're going to go back through this. So let's start up a new screen here. We're going to start by drawing diagrams. I always find a nice little diagram helps out a lot. So we've got our car here, and then we'll also draw in our truck, which is slightly bigger, with a cabin, of course, as well, because it should have a cabin. And then we're going to start adding in our facts. So the velocity of our car was equal to 20 meters a second to the minus 1. And then we have got the velocity of our truck, which was equal to 10 meters a second to the negative 1. Their masses were different too, as you remember. Mass was equal to 1,000 kilograms for our car and the mass of the truck. And I'm going to start putting in car here and truck there. If I can squeeze that in, was equal to 5,000 kilograms. So we've done our facts. Let's look at our formula. Well, the formula should, as you know, be our classic momentum formula. Momentum is, let's turn that off. And let's erase that triangle. Momentum is equal to mass multiplied by velocity. So the momentum then of the car is equal to the mass of the car multiplied by the velocity of the car. If we convert that now, we should have, substituting our numbers in, 1,000 kilos multiplied by 20 meters a second. We keep following that through, we'll have 20,000. Now here's where we could use either the kilograms a meter second to the negative 1 or convert that into sec newtons, 20,000 sec newtons. So the momentum of our car, if I could type neatly, was equal to 20,000 sec newtons. So what then is the momentum of our truck? Well, momentum T is equal to the mass of the truck multiplied by the velocity of the truck. And that should be equal to 5,000 multiplied by only 10 meters a second, which should be equal to 50,000 sec newtons. So we could easily say that the momentum of the truck is greater than the momentum of the car. As you can see there, easily identified with 50,000 compared to the 20,000 sec newtons. So there you go. That's our foray into momentum and the first video I'll be making on it. Hope that helped.